Hello everyone, welcome back to our statistics course again. Now we will introduce the two-tailed test when you know the population mean, especially the standard deviation of the population is known cases. Okay, so the general form for a two-tailed test about a population mean, we can express the null hypothesis and alternative hypothesis just like this. For example, when the WHO claimed that the average age for the people in the world is 80 years old, then you can do the hypothesis test to check whether the claim from WHO is true or not. So your new hypothesis could be mu equal to 80, and the alternative hypothesis could be expressed as mu not equal to 80. So here we can use an example from your textbook. That is World Golf Association. They establish a rule that the manufacturer of the golf equipment they need to meet their rule if their products are to be acceptable for use in the WGA events. So a company named Max Flight they produce a product that is golf balls. Okay, they have a mean driving distance is 295 yards. But such company they know sometimes in the process they will find some distance difference from 295 yards. So today they are thinking about whether they should launch a quality control program to adjust their products in manufacturing process in order to meet the expectation of WGA or not. Okay, so today they need to check whether they meet the WGA expectation or not. If not, they will launch the quality control program. So today they take the sample of the 50 golf balls to monitor whether such manufacturing process should be adjusted or not. Okay, so here you will know the mean distance is 295 yards. So the mu zero is 295. And the first step is to develop the new hypothesis and the alternative one. So here the new hypothesis is mu equals to 295, and the alternative one is mu not equal to 295. That means if the sample mean S bar that is significantly less or greater than 295 yards, the null hypothesis would be rejected. Okay, so the second step for you to do the hypothesis test is to specify the level of significance alpha. And here, the quality control team from your textbook, they selected alpha that is 0.05 as the level of significance for the test. Then such results, you will also find other information from the questions, that is the standard deviation from your population sigma, okay, is 12, and the sample size here is 50. So you can calculate the sample standard error, okay, first based on such formula that is 1.7. Then to think about how to collect the sample data and compute the level of the test statistic. So because the sample size is large, so follow the central limit theorem, we can conclude that the sample distribution is a normal distribution, just like this. The mu zero is 295, and you will get a sample standard error that is 1.7. Okay, in such condition, then you will think about whether the hypothesis should be rejected or supported. Okay, then you can use the p-value approach and critical value approach to check the hypothesis. So here, the next step is to collect the sample data and to compute the value of the test statistic. And because this is a population mean, that especially the sigma, okay, the population standard error is known cases. So the test statistic we can use is z-value. So follow the formula of the z-value, that is S bar minus mu 0 and divided by the sigma, okay, from your population divided by the sample size and get the root of it. You will get the z-value is 1.53. So here you can check your z-value table to find out how much the p-value would be. Okay, so the p-value here is a probability used to determine whether the null hypothesis should be rejected or not. Okay, so you can check the z-value table from the flipped class system or your textbook by Appendix B, okay, to check the z-value is 1.53, how much the p-value will be. Okay, so such condition, you will find the p-value here is around 9370, 0.9370, okay? But here you will find in the two-tailed test, that means your z-value 1.53, okay, larger than such area, or negative 1.53, that means less than such area, okay, you may not accept the null hypothesis, okay? So this is less than such area or larger than such area or less than such area, you will reject null hypothesis. But in such area, you will accept it. So you will find when you check the z-value table, the probability is 0.9370. So the upper tail area for it is 1 minus such value, and you will get 0.630. And because it's a two-tail, okay, so you have to double it to get the total p-value for such case, that is 0.1260. So you may think about such p-value could be used to reject the null hypothesis. Then you have to think about the alpha, okay? Here you will find the alpha is 0.05 and your p-value is larger than it, so you do not reject the null hypothesis. So finally, you can do a conclusion for your audience, that is the manufacturing process should not be adjusted. Okay, so this is the p-value approach for you to do the hypothesis test. Next is using the critical value approach. Here, step 1 to step 3, they are the same. But in step 4, you will find, because it's a two-tailed test, so here the alpha should be divided by 2 first. So 0.05 divided by 2 is 0.025. So you need to check the z-value table again to find out in what z-value condition, okay, its probability is 0.025. Then you will find in such probability the z-value is 1.96. Okay, and because it's a normal distribution curve, so it's a symmetric one. So the negative 1 is also the same, that is negative 1.96. So here, if you using the critical value approach for the two-tailed test, the rejection rule would be z-value that larger than or equal 1.96 or less equal to negative 1.96 here. So you will find, because when you calculate the z-value from your test statistic, you find it's 1.53. Okay, it's between such interval. So you do not, okay, reject the new hypothesis. So in such condition, you can tell your audience that the MaxFly company no need, okay, to launch such quality control program to adjust their manufacture process. So it will be just like this condition, larger or less, okay, then such condition you need to reject the new hypothesis, except the z-value that located in such area. So this is the summary for your hypothesis test in one tail test for the lower upper tail test and the two tail test. Usually the test statistic and rejection rule are similar, except in the critical value approach. Here you need to use is half alpha z-value to do the hypothesis test to check the result. Okay, so the hypothesis test will have 6 steps. You can watch such introduction and to check it step by step. And that's all for your hypothesis testing. Thank you.